Here we go. Okay. Welcome, everyone. Tonight in Dallas, it's the 21st of December. Robot Builders Night Virtual, our last session before Christmas. And we'll just do the usual, go around the table and talk about our robot projects and adjacent topics and whatever else comes up. And with that, without further ado, let's just jump right in. We have kind of a queue already in line with Pat, Murray, Scott, and myself, Carl. So Pat, would you like to lead us off?
Sure. I wanted to thank everybody that I helped drag down into the rabbit hole this week with some programming issues I was having on Arduino, or basically on Arduino program. I had a value that kept going back to 999, and I couldn't figure it out. And with the help of many members in the group, we did eventually figure it out. And it turned out that I was asked, well, did you try putting a hard-coded value for you to compare? And I did without any luck, and it was still having a problem. I found out what was causing that issue, and that I had inadvertently enabled a serial communication routine. And the serial communication routine was going out and updating the value of my max distance, on which led to why my comparison wasn't working properly. As far as I could tell, it was bringing back a 0 on it. So, which was giving me if it was 0 or if it was greater than max distance. So it would come back with max distance as 0. So 0 is greater than, it is equal to 0. And if it isn't, well, max distance is 0. So it was still faulting out. So that was part of my problem there. That is resolved and working. Thank you very much, guys, for the help. The other one I have is into the foray of odometry. So I've been looking at reviewing some of the notes that David Anderson gave us on odometry for he did, and I believe it was prior to our summer our August competition. He had done a discussion on odometry, or well, on basically navigation of a robot. And I was going through his odometry notes, and I decided I was looking for more info on how to implement odometry with a gyroscope. So to try to correct one versus the other. And I came across an interesting article on how to, or a way of fusing the two. So using odometry from encoders on the wheel motors and a gyroscope, and fusing the two, looking at the errors, which is the greater error, and using that result as the correction to the problem. So when your motor thinks it's fine and it's gone over a bump, so one of your wheel encoders, you went over a bump and it thinks everything is good, but your gyroscope says, hey, I got a problem here. You went way off course. So it would turn around, instead of using the encoder, it would use the gyroscope to correct the value. And vice versa. If the gyroscope says, hey, you've moved, and the other one doesn't, so it plays off one and the other, one off of each other. I'll post a link to it in the discussion if I can find my link. And it was called gyrodometry. And I don't know if any of you have ever heard that term before.
Is that from the people up at, oh, my mind blanks out. It's the same guy who did the four-square calibration that we use for a contest.
The Borenstein in University of Michigan?
Thank you, Borenstein. I think gyrodometry was he coined that term.
Yeah, he coined it. So the article, I just posted a link to his paper on it. And it's for a layman guy. It was actually, I was surprised how easily the math was to work through. and come up with a decent way to look at correcting one versus the other, because the gyroscope has drift over time, as well as the encoders when you go over obstacles. So it was an interesting thing. So I thought I'd bring it up and post it. I also found a mention to Borenstein as well from David Anderson's site. So I was on his website and I found an article on IMUs. And he had mentioned Borenstein in there. So that's about it for me. I haven't had much time to do anything else.
That's pretty cool. So, just a question then, follow up. So, David, is that some of the similar approach that you have? And you've noticed, you've discussed hitting bumps and taking one sensor or the other before. You're muted, David.
How about now?
Quite audible.
Most of the odometry things that I do, I learned from Borenstein. So he's got a real expensive optical gyroscope that they use that's probably outside of what we're able to do. But basically, and Pat, I don't know if this addresses your question specifically. When you do odometry when you do location using wheel odometry, basically the wheels give you two things. You sum together the two wheels and divide that by 2 to give you the average of the distance. That number is very accurate. That number doesn't change very much. And, you see the surveyors, for example, when they're doing a quick, dirty survey, they use a wheel about that big around on the end of a pole, and it's an odometer, and they measure things off that way. That actually works remarkably well. And so that part of what you're doing works real well. The other thing you have to do is you have to determine the heading of the robot. And the heading of the robot is the difference between the two wheels divided by the wheelbase. That's the problematic value to come up with. That's the one that drifts when you bump around on things. And that's the value that basically, when you go through that long Borenstein calibration, that's really what you're calibrating. The other gets calibrated in just a few simple steps, but it requires an iterative approach to calibrate that angle. Now, another way you can get that same angle, remember we're sampling this at a certain rate. So let's say we're doing it at 100 hertz, just to make the math easy. At that rate, you're calculating how much the robot has turned during that previous 10 milliseconds. And so you could also have a rate gyro, and a rate gyro basically gives you, rotations of probably in degrees per second or something like that. And you can substitute that into the equation. In other words, when you finally come up with your position in X and Y, it's a combination of the distance you've traveled and the angle. And so you can do that part of the calculation where X position is, the distance times the sine of the angle, and Y is the cosine, or vice versa. Instead, you can substitute in the gyroscope in that intermediate step and not calculate the angle from the wheels, but rather read it directly from the gyroscope. Now, you're correct that gyroscopes drift as well, but they're not characterized in any way the same way that the odometry drifts. So, for example, if I pick up the robot, a couple inches off the floor and rotate it 45 degrees, the gyroscope is not fooled by that. It knows which direction you're pointing, whereas the wheels would have no idea which direction you were pointing. So they do both. The gyroscope, because it's integrated to give us a heading, and that integration is going to over time drift. That's true. By the same token, it's more reliable than the wheel odometry, given that you're driving on a rough or uneven surface where you're getting banged around a lot. I will say on the robot, the RCAT robot, where I spent the most time trying to tweak and hone the odometry, that the building next door to mine has this gorgeous flat marble floor. And the wheel odometry actually does better on that floor than the gyroscope does. But that's the only floor in the universe where the wheel odometry does better. Everywhere else, especially, if you're going from room to room, bumping a wheel up over a door threshold or anything like that, the gyroscope does not lose track of the heading. So it is true that it drifts over time, but it's not subject to those kind of shock-oriented drifts. And I really can't see any other way to make a robot work outside. You just can't go by the wheel difference to come up with an accurate heading outdoors. Is that helpful?
Yeah, that does help. My concern was I have a ceramic floor here at the house. So I've got little bumps and grooves and dips and whatever in the floor everywhere. And then I laid the floor out at a 45-degree angle. So it's at a 45-degree angle to the walls. So I'm going to be constantly have one wheel going over a bump or a little the grout or whatever at a different time. So that was one of my concerns.
Well, I would also kind of disagree a little bit with the first statement that David made about the distance being fairly accurate. I found that, and the nice smooth level floor is great, but anytime you get any kind of slippage, especially like on carpet or outside where you may have a little bit of slippage, your distance traveled versus what your odometry is going to calculate is going to be different. Right. And I found, and it's going to actually be amplified. The second point of David's, what David was saying was the angle. And of course, any slippage is going to be amplified in that angle calculation. So, I mean, that's one of the things I've experienced is the slippage of the wheels. It has a pretty profound effect on being able to calibrate it. If you try to calibrate it, even the square routine, if you try to do that on carpet, it's going to be different than on a hardwood floor.
I haven't found that to be the case.
Oh, you haven't?
No, so we may have different robots that were.
Yeah, I guess I'm doing it wrong then.
I would say that you're using a generalized term slippage that really has to be broken down into two parts. And just say you have a simple differential two-wheel robot, and both wheels slip, let's say a half an inch. Well, that means when you're trying to go 40 feet, you're going to arrive half an inch short of that 40 foot. That's really insignificant. But if one wheel slips half an inch and the other one doesn't, now you're off by maybe a few degrees. So when you get to the target, you might be 40 feet away, you might be 10 feet off from that target because you don't have the right heading. So you can't use the words, and I hear this often, people refer to slippage in odometry. And there are two different kinds, and you can't just use a single term to refer to both of them. It depends on whether you're slipping in the direction of travel or if you're actually rotating. The rotations are deadly. Slipping in the direction of travel doesn't make much difference, and that's why I was saying that number is pretty accurate. The distance traveled number is pretty accurate.
I see your point. And you're right. The rotation, when the wheels are going opposite speed or opposite directions, whatever, and I'm going to continue to use the term slippage, or whatever play your surface has in it, like carpet, is going to be doubled, right? Because you're rotating, so that whatever that angle is, you have to overcome that twice, right?
I think you just have some wicked carpet.
I guess so.
And I think it also would have a lot to do with actually how you've programmed your motor controllers. Because if you've got like a really slow wind up and braking, then you're not exposing the robot to so much slip as if you basically are stopping and starting really suddenly. So I think this kind of gets into the actual behavior of the robot would have something to do with that as well.
Yeah, that could have something to do with it. You're right.
And David's, got the most graceful robots, and they just kind of pirouette and dance.
Scott's robots work really well. So probably what we're learning here is that there are different approaches that can produce optimal results.
Okay, thanks, guys.
I actually was going to ask Pat, has this Bornstein paper and you come up with some code? Have you actually implemented this at this point?
No. So this is something as I mentioned, I've been looking to correct some of the issues going over a tile floor, so that for the main part, I could determine my robot's pose at the end of, 20 bumps, 30 bumps going across from room to room.
Cool. Well, good luck.
Oh, well, I joined late. I just heard Bornstein referring to I have a book of his, I think, like it's called Navigating Mobile Robots. Is that what you have, the book, or you're just talking about some paper?
The book I have is called Where Am I? And it's by Bornstein, and it's about that thick, and it's it's a
I
great.
pasted a link to the Where Am I? It was a talk about it. I don't know if it's the whole contents of the book.
Well, at least when I downloaded it, he made that available as a download for free, and if you work at a nice university, they'll print it up for you, bind it.
It's still available. I just found the link.
Yeah, at one time I would tell you every robot builder ought to have this. In some ways, we've moved beyond some of those, but he covers the basic stuff, and all the math is there. And as a matter of fact, Paul took a deep dive into his calibration routines at one time and published some stuff, which I think is still online.
That's the disadvantage of using the.
Chris, you're phasing in and out of our reality.
Yeah, so I have the book version and the PDF version, I guess. Yeah, it's a good book. I haven't read it in a decade, so.
Yeah, that's kind of where I am. I can actually pull that code up, Pat, if that would be useful, or we can move on if we've finished with this.
Is it? Go ahead, Pat.
If you've got it, it would be useful as where you're implementing, your rate gyro in there.
Let me see if I can make this happen. Present my entire screen. Did that do anything?
Yep.
Coming up.
Okay. Do you have something that says wheel odometry?
Yep.
Indeed.
Determining pose, wheel odometry.
Okay, this is from my talk last summer.
Yep.
So pose is defined as an X position, a Y position, and a heading, which I, for historical reasons, have always called theta. And here's the code to do it just from the wheels. So we calculate a left inches and a right inches by reading the encoders directly and scaling those by clicks per inch. And then we calculate inches, which is the distance traveled as the sum of those over 2. And then this is the tricky one, wheel rate, which we say is left inches minus right inches divided by wheel base. And those are the numbers that have to, especially wheel base, that has to be carefully calibrated. Then you say our theta, we just increment that by the wheel rate. So the wheel rate is in radians and our theta is in radians. So we just increment that. And then this theta float into theta over 2 pi times 2 pi, basically clips it to plus and minus 2 pi, or plus and minus 360 degrees. So that keeps the theta from winding up. And then finally, you calculate the X and Y position as the distance we've traveled times the sine of the angle and the cosine of the angle. Well, if you do look at that same thing, but we're going to stick in a rate gyro. So the first few lines are all the same, and we're actually calculating the wheel rate because I use those for other things. And then I have a gyro rate, which is to read the rate gyro. Now my rate gyro returns, this is by, I don't say it anywhere here, but this is a Z-axis rate gyro. That should be in there. It returns degrees per second. And I'm running at a 25 hertz control loop. So what I really need is radians per 25th of a second. So that gyro rate times pi over 180 divided by 25 puts the gyro rate and the wheel rate in the same kind of numbers. And then finally I say, well, if the gyro is enabled, then the theta gets incremented from the gyro rate rather than the wheel rate. Everything after that is the same. So basically that if P gyro enabled is a flag that allows you to choose whether you're going to use the wheel rate or the gyro rate. And that's really useful for running calibration routines so you can compare the two. In particular, I got the wheels working really well. And then I actually, initially, I calibrated the gyro to match the wheels, just as a rough starting place. Okay, that's all. Stop presenting.
So David, you're running on one version or the other. So you're either using your gyro all the time or you're using your wheel odometry to determine pose all the time.
Exactly. So there's no Kalman filter or Wiener filter or anything like that that tries to determine which one is in more error. And I think as a practical matter, I would say that the gyroscope is almost always more accurate than the wheel odometry. I do have some code. I think I showed a video of it here where the robot, you can give it some landmarks that are basically just corners where it can go and measure the distance to the walls and not only correct its location, but correct whatever drift there's been in odometry. I'm sorry, in theta, in heading. And really, as I say, if you can correct drift in heading, like using SLAM or something like what Chris is doing with RAWs, then pretty much the other errors go away. They're still there, but they're not significant. But the errors in heading are very significant because they throw everything else off.
Okay, so this is all as I've been working to try to get my robot rolling again. My next step is to get it going from 0-0 position to target position. So without tearing up the walls and actually trying to make it and drive it in a fairly straight line.
So Pat, did you ever get to the bottom of that Arduino problem that you posted? There was a big long discussion about.
Yes. So I had a problem. I had a problem where I had a serial routine that was overriding my max distance, which I did not think I had the serial routine enabled. But not only was it enabled in two places in the program. So one of them on serial event, but the other one was being explicitly called. And I think what happens there is it was coming back with a null or a 0. And when it compares max distance becomes 0. So at that point, is my distance greater than 0? Yes. And it would feed back 999.
Glad you got to the bottom of it.
Yeah. So when David had asked me, did I try hard coding a 200 in? I did at one point, but it was still being corrected when it got called to the other routine, to the other, which was the problem. So just bad coding on my part somewhere else.
And the poor code was doing exactly what you told it to do. And we were all sitting here bad-mouthing it.
That's all right. It just reminds me of when I'm working on other stuff, I can find a whole bunch of different ways to not do things.
The peril of global data.
One of many. Well, cool. Well, Pat, we're glad to see that you've got some good progress and prompted such a great discussion. Thank you. So,
well, I appreciate everybody for chiming in, and it was a busy day the other day with that.
Okay, I think next in queue we had Mr. Murray. You've got an update you mentioned. I don't know if this is big or small, but you mentioned some kind of update with the universal update gesture.
I haven't had a lot of time to do any robotics, really. I've had packages arriving in the mail, which is sort of what these questions are around. So there's two things, and one is that I finally, after a month and a half, received the SparkFun VL53L5CX, which is this little 64 zone time of flight sensor. And that works just fine with an Arduino library. And I've been trying to look around for any kind of a Python library for it, and there just isn't anything yet. And it's a relatively new device, but I was just wondering if anybody in the group has actually heard tale of any kind of CPython or MicroPython library that might run that. That's sort of a sideline. The more interesting question is that finally, after 2.5 months, a package arrived from SparkFun, and that's the STM32 micromod processor board on all the pins carrier board, And then this is the other carrier board called the Thing Plus, which is a kind of a longer version of a feather that can hold that same STM32. And so the question is that in SparkFun, I put a post into the MicroPython forum for this, is that I've got an STM32 in my hands. It's unfortunately in the SparkFun world, just like this is, an Arduino device, and they don't talk about Python much. And so what I'm trying to do is somehow flash the STM32 with MicroPython. Now, I've downloaded the Arduino IDE and the ST Cube environment, but there's nothing on the SparkFun site about how to actually do anything except for C and C++, basically Arduino code on these boards. And I was wondering if anybody, because the ST Cube environment is the real programming environment for the STM32, if anybody's ever managed to flash MicroPython onto an STM32, because there might be some relatively generic way to do it. I don't know if there's a MicroPython image for this particular STM32, but I would imagine there is. I can't remember which exact model it is, but there is, I think it's an Adafruit board that uses the same actual chip on it. I think it might be a feather board. But if anybody knows of a way to get MicroPython onto one of these STM32s, either the mailing list or the chat would be very welcome, because my goal here is to turn this into a Pi board.
So does it is it like the RP2040 where you can boot via USB and present that on your computer?
Yeah, I mean, this will show up. I mean, I've got an Arduino IDE with the plugin for it, and it will show up in the Arduino IDE, and I could put a Blink, I could load a Blink program onto it in C++. But there's just nothing online about MicroPython on it or CircuitPython. But
well, when you say you can load a C++, you mean only from the IDE,
right?
You can't just say bring it up as a drive in Windows and drop a file on it like we do the RP2040.
But that wouldn't work anyway, because you have to flash the actual board with the I can't remember the name of the file, but it's basically you've got to flash the board in order for it to not be an Arduino board. Currently, it's flashed as an Arduino board, as far as I understand. When you plug it in, it pops up in the Arduino IDE as an Arduino board. But in order for it to come up as a MicroPython board, you'd have to flash it with MicroPython.
No, I'm
the word flash here, Murray. When you put your Blinky program on there, you are flashing. You're writing to the flash on that card. So there are commands like I use st-flash, st-flash. When you hook that up, and I think this is what John was getting to, when you plug in the USB, it should pop up as a device. And you can actually program it by just dragging files and dropping it into that device if you don't want to flash it specifically. But there's nothing about the board that's unique to the Arduino IDE.
It could be running an Arduino specific bootloader, and it could be, right? And then it could present itself a little different to your computer, as you know. So that's that's where it gets a little into the nitty gritty, where there with the newer USB based ones and all native USB, maybe a little, so I'm not as familiar with those devices, but I know the ones that just do serial, you always had to have a bootloader.
Does it have a separate ST link like these Nucleo boards do?
No. The actual processor is actually just that little tiny board in the center.
No, I'm asking about this little board here that's on the end, which is an ST link board that's used to program the processor. The Nucleos, a lot of the STM stuff comes with this.
I'm not sure what you mean, David, because this doesn't have anything to do with ST products apart from the actual chip itself. I mean, the whole SparkFun architecture, I'll show you, is that this is the actual STM32. They call it a processor board, and then it fits on a carrier board. This carrier board is nothing really except a kind of it just exposes all the pins. It doesn't have a programmer built into it at all.
So the main board itself does not have a separate ST link hardware programmer.
nothing like that.
Unlikely.
And
But
no, it doesn't. And for example, here's the feather board. It's, you know, this fits onto the feather in the same way. And so like that. So you end up with a feather. Now, the one thing I will confirm is that I think it's the UF2 bootloader. The bootloader that's currently on the board boots as a USB device. But if you want to, I'm using the word flash. If you want to flash MicroPython, what you're doing is you're loading a MicroPython bootloader that expects to look for a main.py file and automatically execute it when the board is fired up. And that's sort of what becomes MicroPython as an operating system, is the bootloader that automatically executes the main program when it fires up, rather than just mounting it.
Yeah, but Murray, is it an ST board chip? It's an ST chip.
Just the chip itself, but the boards are made by SparkLine.
Okay,
So,
but if it's ST chip, and I
Mhm.
believe there are micro, and if it's got enough memory, there is a MicroPython port to ST boards, I believe.
but you have to have
So
an image. You have to have an image specific to the actual STM32 model.
yeah, so
And
you're gonna
so-
need
Yeah,
that,
but-
and then
but
it sounds
what-
like you're gonna need
is
a
that
way
model-
to get it in there.
yeah, but is the model that you have one of the boards that's supported? Because I
I-
believe it's a big list of ST parts.
Yeah, and to come to think of it, I'm pretty sure that the actual STM32 that's used on the processor is the same one that's used on the Adafruit Feather STM32. It's like the only Adafruit product that has actually got an STM32 on it. And I believe that the MicroPython team have targeted that particular model, and it may have. I think they have an image for that board. So what you're saying is, if there's an image for the Adafruit product, it would probably work on this one because it's specific to the ST chip.
Yes, and
that
then
correct?
what I would think is, because the rest of it is just a support board. I mean, it's
Right.
just pin out. So, you know, one of the
But-
things that you might have to look at is what pins do they dedicate to what functions, because I believe in MicroPython you have a class that's called machine, and in that machine there, that kind of defines the IO and the
Mhm.
the I squared C and all of that other stuff. So you might have to look at that. But it sounds like you could, I mean, what's the worst you can do? Could you reflash this if you had to?
I'm sure, yeah.
I mean,
It's one of those things where I just got it. I think today is Wednesday. I got it on Monday, so I haven't really had a chance to really dig into it. But I mean, it's a really cool concept. I've been trying to talk our motor controller team into trying out using these M2 connectors and being able to, mount one of these. But it's kind of one of the things where the cost of the processor board is around $14 US, I think. And so they're a lot more expensive than, let's say, buying I think an RP2040 chip is like $1 or something like that. So it's a lot more expensive. But what I'm thinking at this point is that if I can get this working as a Pi board, I don't think I'm going to end up using the small one because there's not very many exposed pins. But this ATP, all the pins one, it literally exposes every pin on the STM32. And the form factor is fine. And if you blow the thing, you're blowing the processor board, so you only replace the processor. And you can swap out RP2040s. There's like about 5 or 6 or 7 different chips you can put on here. RP2040, STM32, ESP32, SAMD51. I can't remember all of them. In any case, what I'm thinking is that either the Pi board or maybe more likely this might be the basis of a robot. And so for my Mars rover, I would run my robot on this and then probably put like a Raspberry Pi right next to it and use that for Wi-Fi and communications, but actually run the robot on the STM32.
So I just just Googled MicroPython and STM32, and if you just keep on clicking through, they seem to have something here for the Micromod STM32. Is that what you have?
Oh, really?
Yeah, so if you just Google MicroPython and STM32, you'll wind up on the MicroPython website, and in a couple more clicks, you're on a page specifically for the micromod STM32 MicroPython. Now, and they mentioned something about ST-Link, and I was going to mention that because if whatever is in Flash right now somehow gets in the way, you might need an external ST-Link programmer that, people who use black pill and blue pill type boards have that, because it's not built into those $3 STM32 boards, and I can't find mine right now, but it's like a $10 little device about this big,
Okay.
and it has
On the search, what's the domain of the search? Is it micropython.org or is
just let me post the URL here.
Oh, okay, thanks.
But they talk about how to program it, and there seem to be two options. One of them is ST-Link, which what David was showing is kind of the version of ST-Link that's built in or attached to some boards. But boards that don't have it built in, you can get a $10 external dongle that implements that ST-Link, functionality, which you might need, to have kind of full access to the flash of your micro.
Well, as far as I haven't actually had a chance, I've just installed it this morning. Is I've got the ST Cube environment that I've just installed, but can't you, using that without the ST-Link, can you connect up to the ST32 without the link board? Or do you have to have the link board?
Well, again, if there's a bootloader in there, I don't know if the STM32 Cube IDE cares much for that bootloader. It may not, right? I mean, there's these USB bootloaders that we just drop a file into what looks like a disk. They're called UF2 bootloaders, and I'm not terribly familiar with them. I've just used some of them, but the IDE, the STM32 IDE, doesn't really care much for that. It does. I don't think it works with that kind of bootloader. So to get rid of that bootloader, that's where you need more low-level access to the flash. That's where you might need that ST-Link dongle. But they're talking about this other method. Exactly. That's what I'm talking about. $10.
You can also, if you have one of these, I don't know if you can tell that you can actually detach the ST-Link.
Yeah.
Which can then be used as an arbitrary ST-Link for reprogramming this board or any board.
They're also talking about this DFU method, which does use USB. So it's another method to go in through USB, but not using this UF2 bootloader standard, but using some other mechanism. Again, keyword there is DFU. I personally haven't used that, but I've seen a lot of references to it. But that page that I put the URL, in there, they're also talking about how to do that. You gotta, put your micro into the DFU, device firmware upgrade mode. I'm guessing there's some ROM on the chip, then that sort of executes that bootloader that's in ROM, and then you get in there without needing an external dongle. But again, you don't have debugging capabilities, which you may not care for, and there may be some other limitations in fine print. But that's another way of getting in there. And then if you look at that page that I sent you, right, they explain maybe how to do that. So you might be in luck. If you just follow the instructions, it might just work.
Yeah, because basically from the micropython.org site, you download a single file that you use to flash the STM32 board, and once you've done that, it just it's a Pi board. Then,
yeah.
Once you've done that.
So it looks like the file and the instructions for how to use the DFU method of programming are there. So.
Okay, cool. All right, thank you. So that's kind of my excitement, trying to get that running, because if I can get this board running as a Pi board, I kind of like the Pi board, but it seems a bit strange and limited in terms of hardware. Whereas this is, it's not that big. It's about the size of a Pi, but it gives you all the pins, and I want all the pins, and it looks like a great. I mean, David's got his, the ST boards, which would be fine too. But for some reason, I've ended up with this, and I kind of like the idea. So we'll see how it works out.
I think the Featherboard is also programmed that way, Chris. There, you hit the reset button twice and it puts it in a download mode from their own bootloader.
But I think the ST family has boot mode pins. So it's a matter of what the pins are set to when the power comes up and where it looks. Because I think you can actually bootload into it over serial or USB. I think there's a number of options, but you're right, Chris. You have to have low level access, like a JTAG or control the boot, the boot up pins on that part.
Now the JTAG, I mean, again, I haven't used the DFU method, but that relies on the built-in USB capabilities of the micro, but you do have to put it into that mode through a special pin. But then all you need is USB, right? You don't need any additional ST-Link type or JTAG dongle. Again, I've never used that method, but there seems to be a feature built into some micros.
Right, but the thing you got to remember is that's just a bootloader, and a JTAG access will give you debug capabilities. Sometimes, you can have a bootloader with a serial debugger or some external communications link, but
he just needs to get his Python engine in there, right? He's not gonna, he doesn't need debugging, but he doesn't need debugging capabilities.
No.
See, you mentioned DFU, and I find that interesting because, as I've mentioned, I'm playing around with Esperino, and those are based on the Nordic chipsets. So this, for example, is a JavaScript powered watch that runs on an NRF52 series thing. And whenever I update its firmware, I actually updated through the NRF toolkit in my phone. And as you can see, it has this DFU mode. So I don't have to use any pins or USB or anything. I click this button, I select the firmware image, it pushes it over Bluetooth, and it flashes the chipset. And they call it DFU. So I wonder just how generic of a term that is.
Yeah, it's a generic term. I'm not sure there's really a one standard behind it. I think it's more of just a generic term that's used for that use case, and I doubt that it's all the same standard technology that's used across all devices. I don't think so.
Like NXP calls it in-application programming, or ISP. So there's a couple of different terminologies for it, but yeah, that's ST's term.
But I do have to tell you though, when I hear about all these special pins and wave the bag of parts over your head and hold the JTAG emulator just right, I think of just how easy it is to flash new firmware to my watch. I think this is the way to go. That's definitely, it's not going to do JTAG debugging. So Scott, you got me on that one, but in terms of just simplicity, it's pretty cool.
Well, and again, that's sort of like I've been using the the Adafruit Itsy RP2040, and to get MicroPython onto that is like a minute. It's just so dead easy, and you go from having a C++ board to a MicroPython board in like a minute, and you download a file, do something, and it's just done. And this is my first STM32, and as you guys all use them I've been using them for years. That's probably why I'm giving a shot at this, because clearly it's a popular board in the club, but it is certainly more difficult than the RP2040, which is just easy. There's just nothing complicated about it. And all these hardware and software and the ST Cube environment and all this, just to flash a board with MicroPython, it's like, oh my God, it's quite a lot more difficult. Yeah. And it seems like ST as a company just has this history of insane complexity. I mean, my God, going over their website and even just choosing a board is difficult. There's just so much there.
Murray, you remember what it was like to get a firmware on a processor in the 1980s?
Well, okay, there we are. But,
okay, so
the age.
So what's changed, right? No UV light.
Exactly.
You don't have to sit it out in the sun, so you can make it fresh again.
You need to be in a tin shed in the sun. That's really what you need.
Things are so much easier nowadays. It was, in the 80s, 90s, like the 80s, it was an adventure trying to program, a robot onto, like I say, I used the Motorola HC11 chips. Mm-hmm. And that became a little easier because it was a serial interface or a parallel interface that you built. Nowadays, holy cow, you plug a USB cable in somewhere, whether it's a Cube IDE, STM Cube IDE, or
a robot with an HC11. Is that what we see, David? Oh my goodness.
yeah, exactly.
Wow.
And that was modern. That was a fairly easy way to get a program on a chip. Before that, like you say, you were an EEPROM with an E squared prom burner or something to get a program on. That was
And there's
difficult.
those paper tape robots too, the paper tape robots.
The cool thing about the HC11s was that it came with all that I/O, which was like a huge thing. Before that, we were trying to build robots out of 6502s.
Yeah, it wasn't a microprocessor; it was a microcontroller.
There you go.
So you had the peripheral chip built right into the processor to give you, a really easy way to interface real-world applications.
But then when they introduced Motorola introduced the 68332, you have basically a 16-channel coprocessor to do all that hardware. And we had 32 bits and a big flat memory space. And, whatever it was, 16 megahertz processor.
I still have one of those.
I could bring another robot over here and show you.
I don't have the software to run it anymore because to compile the program, it was on diskette. Shows you the age.
Well, my first robot had an S100 bus on it, if that says anything.
That must have been a big robot.
It was using the 1979 Z80 starter kit, which was it was about that big square. And hex keypad with LEDs with, I think, 4 S100 slots.
Word star.
There you go.
Harold in his wire up kingdom over there. That's
Z80 with a.
Yeah.
This is a 68. This is 68,008. So we just only had to wire 8 bits to the bus to run through, and then we've got the 6868. I think that's the memory controller, or something along those ways. We got 2 or 3 of those things from that Motorola chipset you guys were just talking about.
Jack, are you paying attention to all this?
And we got the we had a burner. We just kind of put it into the burner and we hit the light and we did the light thing on it.
Harold, do you have that soldered in place?
No.
It's on the socket.
This is wire
looks
wrap.
like wire wrap.
No, but I mean the EEPROM.
No, it's just inserted.
Harold, is that EEPROM in your steampunk lightsaber?
Oh yeah, that's what I want to talk about with the lightsaber because I was at Disney World. That's what wasn't here last week.
Okay, we'll come back to that later. I was
back to me. Come back to me.
I was making a big gamble on what that was. So, okay.
In any case, thanks for the discussion. I think I will just mention one thing before we go is that the one thing about this big ATP board that is actually not available on the small one is this one actually has an SD card slot on the back, and the big one doesn't actually, which is, not a huge deal, but it's nice to have that SD card on the back because that's where I would actually put all my programs. But in any case, we'll see what I can do in the next week or two. I'm actually switching jobs, and I start my new job on the 12th of January. So I've got my wife is in Tokyo, and so I'm a bachelor for the next 18 days with nothing to do except clean all the mud out of my basement and work on other projects. So
Get your plumbing leak fixed.
Oh, and our collaborative motor controller project is kind of taking a different turn. I put 3. Let's see if I can get it here. I assembled 3 of these boards using my Easy Make oven, reflow oven, and all 3 of them fail in different ways. So I'm convinced that these little tiny QFN parts, that have the exceptionally small pins, they're just, I think that's the problem. It's just impossible to get them placed without creating solder bridges that you can't get to. So
I think we have confirmed that John is definitely a masochist.
is what?
A masochist.
A masochist?
My
Well,
God,
well-
you've gone through some pain in the last week or so.
Well, the fact that I've tried it 3 times, in hindsight, when you build a prototype, it's probably wise to have lots of test points on the board. Because that was the biggest problem, is that I couldn't figure out what was wrong with it. You know, all I could do is inspect it for solder bridges, and I could measure voltages on various different points. I could verify there were no shorts anywhere, at least that I could see. But 2 of the boards, when I plug them into USB, got really hot. I mean, to the point where I was afraid I was going to burn out my my USB hub. 2 of them actually booted would boot to USB, whereas one of them that would get hot, it wouldn't even boot. The one that didn't get hot and did boot, the driver chip didn't work. So, I mean, I threw in the towel and let. We've got our other member of our group is now pursuing a one that does not include one of those tiny QFN packages. He found a different driver that you can hand solder.
Yeah, he
John.
got a castellated RP2040 board as a single board that he just solders right onto the motor controller board that he designed. So he kind of avoided all of John's pain.
John, the QFNs that you use, do they have a large power pad in the center?
No, they're.
No?
I put a picture of them up a couple of weeks ago. The driver chip is something like a 3 millimeter square. I mean, it's incredibly tiny. And then there's the RP2040. That was, I mean, I actually had, I guess, 2 of the boards, the RP2040 actually worked, because it would actually boot to flash, boot over USB. But one of them, it wouldn't even boot. So I guess I was better off. I was more successful getting a RP2040 correctly soldered with its associated parts than I was the driver chip. But who knows?
Well, no, on QFNs, especially like a power one where you have a large center pad, you have to window the stencil, or you have too much solder built up, and you get a basically a mountain, so the chip doesn't lay flat because there's too much solder under it. But if you're the size parts you're talking about, they usually don't have that. So I was just going to make that comment for anybody using QFNs, that you have to, and they recommend 20 to 30% windowing on any pad larger than, I think, a couple of millimeters square. It really
What do you
helps.
mean by?
I've seen that in my own work. It really.
What do you
does
mean
help.
by windowing?
Instead
It's like
of
a grid
one
pattern,
large-
right?
one large pad in the stencil, you actually put like a frame, like mutton bars on a window. And the width of those bars that are across that pad basically need to be about 20% of the surface area. So that's what I mean about windowing. Instead of one large pad, you have several small ones. So that way the solder has a place to flow, a void to flow into, and the chip can lay flat. It doesn't puddle up and create a crown, where then since there's no legs to create surface tension to pull it down to the board, it just seems to muddle on top of that crown, and you always get uneven connectivity on one side or the other, depending on where the crown takes it. But when you window it and you have several small squares, then it lays flat and it'll pull right down.
That's pretty cool. John, sorry to hear about the challenges you're facing. So, I guess does that consume most of your week? Have you had any other more fun things to tackle, or are you just struggling?
Just
with
the mechanical lines that I'm working on. We're gonna, next year's Halloween project, have eyes that follow, that basically would use a camera, detect faces, and have eyes follow them. The modification of the project I found online.
Uh-huh.
But
Okay,
we
cool.
won't cover that yet. It's maybe in a couple of weeks I'll have something presentable.
Sounds good. I think next in queue we had Scott, and then I'm ready, and then I'm guessing Harold. Did you want to jump in then after that? Okay, cool. Anyone else want to jump in and get in queue after Harold? All right, Scott, let's take it away.
Well, first, Murray, I want to say yes. ST does seem to complicate things. I normally work in the NXP family, the 1700 M3 core family, and about 6 months ago, I thought, let me try out these STs. Maybe I'll port some of my peripheral drivers to ST. So I started looking at the register sets, and you're right, ST makes it just about as complicated as they could. Because I'm thinking I could port this pretty easily. The register should be similar, but especially when I got into the timers, there's just so many different options with the ST timers. It's really crazy. And if you look at the ST Cube, it has another application to configure the peripherals and configure the pins, because all of that, the driver hardware seems to be so complicated and overly complicated. And especially for someone who's not used to getting to that level of a part, even though I am familiar with that, I found it very difficult. And I think that's why there's so many tools that kind of abstract you from that.
Yeah, because that pin programmer thing, I went through that, and it's my criticism of ST isn't that they don't need to do that. It's just that they've set up a business model where they've got so many options, and it's so powerful. But it from someone coming in from left field, it's just impossible.
Well, I think all of that flexibility and that configuration, that configurability, if you will, is what makes it so flexible. And that's one of the attractions, because you can keep with the same family and you can do a lot of things with it. One of the things that drew me to the STs was being able to have multiple encoder timer modules. The NXP platform has a QEI, they call it quadro encoder interface, but it's only one per chip. And that's why a lot of my robots have multiple processor boards, because each one of them is taking care of one wheel or the other, and the motor and the encoder interrupts. And so that was why I thought, well, I'll just do an ST and I'll have a single micro on this robot. But I got my fill of it, let's say, and maybe one day I'll get back to that project. But right now I'm on to other things.
Well, Scott, the appeal of the Pi board is that for someone who's interested in programming in MicroPython, is that I didn't get that Pi board until maybe about a month and a half ago. And the first time I plugged it in, it pops up as USB. I can drop files on it, and I actually have, as they say, a MicroPython operating system, and it's dead easy with an STM32. And so I think the guys that developed that Pi board were really doing everybody a big favor, both from the hardware and the software side, by developing an environment that anybody can use. It's just, Adafruit's gone to this huge amount of trouble to create CircuitPython, which kind of just sort of derails the MicroPython project to some degree, because they're marketing CircuitPython. But MicroPython on the Pi board is really, really amazing as a single, entry point. You plug the thing in and it's just running MicroPython. And then you can load files on it. The structure of it's all there. You got all these library files already there for you. It's really nice. And it's kind of a shame that ST doesn't have that as an entry point, because the entry point into the ST world is like this giant mountain you climb.
Well, I think ST's target customer is different than the hobbyist.
Sure.
I think ST is not really designed or marketed to be in the hobby realm. It's much more of an industrial type of platform, which I think is why it's so flexible and it's so, of course that kind of equates to complex if you're not familiar with it. But yeah, there is quite a learning curve. I was on that curve for a couple of months and then I got off of it. So
Well, Scott,
Well,
I have to agree with you. And my only caveat would be that I went ahead and stayed on that curve for, a year. And I've got all those pages in the manuals bookmarked where I can get to them, where it tells me what the alternate functions are.
Yeah.
And actually have figured out how to make all that work. And it is very powerful. The fact that little tiny, what is it, 5 millimeter square chip has a full function DMA controller and a nested vectored interrupt controller and all these hardware functions you were talking about where timers can go off by themselves and become encoders or generate pulse widths or whatever it is you need. That stuff's all pretty powerful, but it's a puzzle. And you really have to sit down and work through the puzzle. And there aren't really any simple shortcuts to that, which I think is the source of frustration that maybe both you and Murray are expressing.
Well, I found it frustrating that the ST Cube tried to remove you from that. Some people may like that. I didn't particularly care for it, so I tried to go back, and even the IDE kind of fought me at some times. So,
I don't use any of that.
Yeah.
When I say I use the ST Cube, what I mean is I use the libraries.
Yeah, I actually have a plugin for Visual Studios called Visual GDB, and it's like a cross compiler, kind of a flexible CMake file interface for Visual Studios. So you can use the IntelliSense and the editing and all of the helpfulness of Visual Studios, that you can basically cross compile, use a local version of Visual GDB to debug it. You still have to have the physical interface we were talking about earlier, like a JTAG or a VSP. But once you have that link, it becomes a really powerful, very easy to use platform. But configuring it tended to be quite a pain in the neck. So,
I agree. But also, I think your point is well made that the complexity that's frustrating is also the source of the power of that little chip.
Yeah.
It's a little bit like saying, the violin's a wonderful instrument, but it's just too damn hard to play.
And it's a classic trade-off, right? Complexity versus power.
Yeah.
It's really hard to have both.
And I have to say that part of the appeal, though, of that chip is the hardware. That that you compare it to almost anything else, and there's the ESP32, and there's lots of other, there's other alternatives. But I am drawn to the STM32 just looking at what you have available as hardware. It's pretty impressive.
Yeah.
But getting to the point where you can run it on, something like this is going to be. Although I thank you for the link. I think it was Chris that put the link in. I've got the link now, and I'll give it a try. I'll give it a try with that DFU bootloader thing and see if I can get it going. Because if I can get MicroPython flashed onto here, then I'm going. It'll be great. Thanks.
Well, I wanted to kind of just share an update for belts that I've been working on. Speaking of different parts. And one thing that I came across, and I know most of us that have dealt with Raspberry Pis and trying to make a robot run, especially with sensors and cameras and whatnot, we're always looking for more UARTs, right? I mean, the Pi's got basically one UART, and then we're plugging in USB stuff. So I found this board, and basically Mauser sells it. It's a FTDI chip. It's called an FT4232H mini module, and you plug it into USB through the Raspberry Pi or whatever your board is that has USB, and you get 4 UARTs, 4 serial ports come up on it. So I found it really helpful. I'll just take the camera. I'll show you my. So basically, this is belts, if you can see it. I have my H bridges on either side that are running the motors, and my Pi. I've got a Pi 4, and so I've got my USB to serial chip here, which is running the GPS isn't in the socket at this point, but also have my AHRs and also a link to. I have a telemetry link. I have a telemetry radio that I radio back information. So it's been really helpful to have, all those UARTs available. And I thought it was a pretty cool little board. They also make, and this one I had to buy straight from FTDI. This is actually not only USB, but it also replicates USB hub, and it has 2 serial ports on it. So you can basically plug this into like your Raspberry Pi, and then, still have additional USB and 2 more serial ports. But I couldn't find this on Mauser. This I ended up ordering straight from FTDI. But these are both, they're like $25, $30. So they're pretty cheap, very helpful little parts. I just wanted to make, let everybody know that they were available.
Scott, could you put links to both of those parts into the chat?
Yeah, I'll have to go on Mauser and get the.
Well, just put in the part numbers then.
Okay. But that, that's, I'm still working on a lot of software. Of course, the Raspberry Pi on this one has been causing me some trouble, and trying to get it straightened out and get the getting my code to compile on it and run. So, but I'm getting there. It should be ready for next year whenever we have the next Robo Columbus.
Excellent.
That's no fair. You can't start this early. That's not fair.
Is it
Do what?
It's not fair to start this early.
I don't know.
Yeah, it is.
He's got the same time that we have, Dave.
Yeah.
Yeah.
But is it
Except
going to
he's-
look? Is it going to look like a tractor?
No, it's gonna look like a mud bog.
I'm
monster
totally just poking. I'm totally poking and teasing.
I know you are.
Just
I don't
FYI,
know if I'll ever live that one down.
I'm getting the base for my next Robo Columbus robot for Christmas.
Cool. And how does Santa know that's what you want?
I was indicating with my finger on the screen.
I thought you were going to say you've just been an extraordinarily good boy.
Well, no, I tried. My wife has a very good cup. Says you were naughty, you nice, you tried.
Packages
like
just
a
show up on the
participation
doorstep.
trophy?
What's that?
Is that like a participation trophy?
Yeah, sort of like that.
My
Pat,
Christmas presents just show up at the doorstep, and I give them to my wife.
Pat, I just recall that I answered your question earlier inappropriately when I was showing the code for using a gyro with odometry, and you said it's always one or the other. That's true now, but actually when I first set it up, I did it to measure the distance between the two and only use the gyro when the difference was large. But what I found when I started running tests was that didn't actually work any better than just running the gyro by itself all the time. Originally, I thought I'll use the gyro to correct errors from the wheel odometry. And so I would difference the two and just use the gyro when the errors were large. It wasn't any better. It was actually better just running the gyro itself. So.
Okay, so that's the question essentially I was looking at is why run the gyro all the time? And you've answered it there that you didn't notice that the error was worthwhile essentially correcting.
No, and I spent a lot of time working on the code that would trigger when the value was long enough and have a smooth entry and smooth exit from that. And for all of that, it didn't work any better.
Okay, no, thank you.
Scott, very cool. Okay, I guess I'll jump in then, and then we'll go to Harold. So I wasn't able to get very far this last week, but I did dig this out and start to work on it again. The old duct tape and baling wire namesake, and I just have to say that I couldn't get it to do what I wanted, so there's no video today, and. But I didn't also want to go for a poop-colored flop star just for participation trophy. So anyhow, the issue that I came across is I just now had it. I'm done with Arduino. I'm moving on, and that leads to my next questions. My next questions are, related to Linux and Raspbian. Suppose you've got a service that launches every time you boot, like the Raspberry Pi or Linux. I have two questions basically. One is, any recommendations for the best way is, can you attach to the console output of something that's run as a service in the background? And then the other question is any recommendations for utilities? So is there a way you can have a utility that monitors whether process is running and then restarts it, or if it hangs or is not running? And like,
Sure.
Can such a utility run on a pre-compiled program, or do you have to have hooks built in when you?
There's some tools built in to do those very things. Most of the time, when most people will run something in the background on a Linux box these days, they're going to be using something called systemd. And if you look up, the command you're looking for is systemctl. And that starts it and stops it, and you can set things up in it and a whole bunch of other things. It's got a whole deal in there about how you set these things up to make them run. Then when you're running underneath that, there's a journal command that you can go grab, that you can go do that and tell the journal command to go, any of this output that's coming to like the console, instead of just logging it or doing whatever you're doing with it, put it out to my console and go grab that. And then I think there's some monitoring and stuff, so you can ask, and one of those things you can ask, is this thing running, or how's this thing doing? That's so as well. But systemd is what you're looking for, I believe, Carl. And the systemctl is the entry command into that.
And I'll post a link into the chat, but in my current robot operating system is KROS, but in my previous ROS, I actually have a couple files that are Python files that run up on system control or systemd when you boot the Pi, and then whatever that Python file does, it runs, and you then have a command line access to it treats it as a system service that you can check the status of or reboot or restart it or whatever. It becomes like a regular Linux process. And so I'll put the link in, but it's actually, there's about 4 or 5 different ways to do it in Linux or Unix, I think. But probably, I think Harold's right. Probably the easiest one is a systemd running with system control, systemctl.
Yeah.
And then you can check the status and see if it's running and all that. And you can run Java, Perl. You can run anything you want as that script. And I'm using Python, but I'll put the link in.
Yeah,
You
and
can also
this is
set
one of
up
the most
the service.
straightforward. Go ahead. I'm sorry. Please go ahead.
You can also set up the service to be persistent, Carl. You were talking about having it restart, because there's all kinds of conditionals of when the thing starts, like if it requires Wi-Fi or requires some graphic element or whatever, you can put those conditions, and I forget what the file is where you set up the service.
Init tab.
Yeah, it's within the systemd.
Yeah, it's going to be some kind of manifest type file that he's talking about.
Yeah.
It's going to say, I need all these things before I can actually do stuff.
Yeah, or if I stop doing stuff, restart it.
Yeah, and how many times and when to give up and all that kind of stuff.
Carl, I don't know if you're familiar, but in Linux, any command you can type in on the command line, if you end that command line with an ampersand, then it forks a shell and runs that separately. And that will continue running in the background. As long as the output of that is connected to your terminal, if you exit your terminal, the program will exit. But if you reconnect its output to something else, then you can exit and that will continue to run. So that's just the basic piece of Linux. Any command can be run as a background command. And then secondly, at least in traditional Linuxes, there's a file in etc. called init tab, INITTAB. And init tab was originally set up to initialize things like Gettys running on terminal ports and so forth. And you can, you can tell it what program you want to run, or programs you want to run, and they will also restart them if they die.
Yeah.
That's part of that function. So now this all predates.
That init tab thing was how it was done in the old days, and I'm not trying to be.
But that all predates.
Started. And
that all predates systemd.
Yeah, the system D came along, I don't know, 8, 10 years ago, something like that. People
But you
kinda
don't need
migrated to it.
system D if all you want to do is run a task in the background. All you've got to do is put an
Yep.
ampersand on the end of the line.
You're right.
But if you want that to be running when you boot your Pi up, then you probably want. I mean, probably the easiest is System D.
Yeah.
Well, there's one of those files because I have. So basically, what I'm doing here is that I've got it's Bluetooth to MQTT gateway software, and and then I also have Node-RED. So I think I have Node-RED running all the time, but then it just launches and runs in the background. I don't care about it. But I've had some issues with the Bluetooth to MQTT gateway on its consistency, and it also I mean I can show you, but it has so when you launch it, it displays some kind of useful stuff if you want to kind of like monitor what's going on. So what in the world is whoa, what is, oh, because I did this. Okay, yeah. So you can see that it does this stuff to the terminal where it lists the kind of Bluetooth devices that are advertising that it detects, and then for each of their MAC addresses, it lists their RSSI. And you can see that it goes back and I guess it uses the whatever those commands are in the terminal to go and update values. So this is what I was thinking, that rather than having to launch it like I do from the command line, which then it doesn't automatically restart, could I get this to run at, I mean, would the system D do it where it would launch this, fork a process, and have it output to some terminal somewhere, and then should I want to look at it, I could attach to that terminal and see what's going on?
I think the answer is yes. I just looked. I've got a CentOS 7 and a CentOS 8 system here, and I just looked to see what is in init tab, and what is in init tab is all commented out, telling you how to do it with system control and system D.
Are there some good links in there? Some good learning links for system control?
Well, just if you're on a Linux machine, just do a cat of et cetera init tab, and it says, don't use this file, do it like this instead.
So cat. So is it like tilde slash, or where is it? I don't know.
Slash etc slash init tab, INITTAB.
And Carl, the link that I posted for using System D is actually a System D config file, but the comments in it tell you how to use it. So
looks like you don't even have an init tab.
Hey guys.
I don't even have a init tab on Raspbian. Okay. All right. So they went straight to system control. All right. I'll be learning. Thank you.
Yeah, I would add that the man page on System D is opaque, to put it mildly, and the man page on System Cetl is similarly opaque, but it's really very just a couple of commands you need to know. If you run System Cetl status and then the name of your service. So services have names. So like if you got snapd running, you can run System Cetl status snapd, and it tells you where the snapd service is active, and it gives you about the last 10 lines of log. And then journal Cetl, which some of these options have to be run with under sudo. So, it'll hit you up and say, sorry, you can't do that. Run it under sudo. But journal Cetl will give you all of the log output from that service. So really, there's only about 3 subcommands under systemctl that I found useful. Stop, restart,
stop,
and
restart.
status. And then the
Also,
journal feed'll
enable
get the logs.
To enable and disable is useful if you want something to run across boots. But you're right. There's only about 4 commands you need to know.
Cool. This is what I was looking for. Cut to the chase. Straight past the opaque, whatever. And
well, there's a lot of things that you can do with it. But basically, you have to enable a task. It'll build a symbolic link. And then when you start well, I think you can actually start it without enabling it. But then you can start the task and restart it, and you can look at its status. And the systemctl command is pretty wise about when you give it wrong input, suggesting what you meant.
all right, so it makes up for the lack of a man page.
It's hard to screw it up. Not impossible. Not impossible.
I like the sound of that. I'll still break it, but
okay. Anything you have to run as root is potentially dangerous.
Like much in Linux, the man page is perfectly precise if you already know what it means. But if you don't know what it means, then you're pretty much up the creek.
Yeah.
Nice.
Well, put it this way, I've used kind of a lot of these, as probably David and others have as well, but on a Pi, I just found that systemd or system control is just really easy. And like I said, I posted that link in that just gives you kind of the beginnings of one of those. And on a Pi, it's kind of the most modern way to do it. And it's probably, I think, probably the easiest. I mean, you don't really need a huge, complicated man page. I know this goes back to our earlier discussion of doing everything in assembly on a 4-bit processor, but it's, it's not that hard.
Yeah, I'm actually using the system control for my street security camera, and I've got the window up right now. If you want to take a quick look, let's see.
Well, what I used it for was that when I turn my robot on, I've got a toggle switch that's an enable disable, and it runs a daemon in the background. And if I turn on the toggle switch, it starts running my robot. So it's pretty easy.
I don't know if you can see that.
Yeah, it's a little small.
Right. So you see my, so I just did here's my LPR server, license plate reader server status.
There it is in the last few lines of whatever.
Yeah. So that's basically just, I'm logging. It shows you what I've been logging to the monitor there.
All right.
So, and let's see, and I'm just basically launching a Python script with the shell script.
Huh.
If you just look at LPR server service, that's it. That's the configuration file for the process I'm running there. But basically, you take that service file and you install it with systemd, and it basically says, hey, when I start up this exec start, run this LPR server.shell script, and it's got just one line in it. It basically says, let's see where I lost it here. Yeah, right here. It says run Python on this Python script right here.
Yeah, okay.
And that's it. It's just 3 little pieces.
Perfect.
So anytime I start up and shut down, when I come back up, the the script will automatically start running.
Okay, excellent.
Yeah, and this is also the one I'm using on my letterbox robot. Same idea. So if I power down and power back up, my letterbox comes back up again.
Okay,
And
that's good.
One trick that's not immediately obvious is when you run journalctl to look at the entire log, you need to give it the minus U and then the name of the flag of the service. So whereas systemctl just takes the name of the service as is, prepended by some operation like status or start or stop, journalctl takes a minus U and then the name of the service, and then it'll print out the logs. So you can run journalctl minus U cups, for example, and it'll print the entire log emitted by the CUPS printer service.
Which is a very happy and active service, even when there are no printers involved.
Oh my goodness. All right, so this is going to be interesting when I figure this out.
More than you wanted to know, Carl. You'll be sorry you asked.
Well, it's it's always dangerous to ask a question like that in this place where so many people know what's going on like this.
So what's your use case? What are you auto starting? Just I guess your main robot logic or something like that?
No, it's a Bluetooth to MQTT gateway. So MQTT is a protocol for sending messages around, and the BLE. So this is back again to my my Espruino NRF chipset kind of thing that runs JavaScript. I mean, they have wireless connectivity, and so let me go full circle because I think the problem I ran into on this is that the values from up here on the camera, which is an OpenMV Cam H7, are not surviving the UART serial connection down to the bane of my existence, this Mega 2560. And there's just too much going on with the Arduino Mega at least on this. I mean, I ran out of timers, so I had to use a software servo. And I noticed, and I was trying to console log, the standard, what the hell's going on, just to look at values coming down from the camera. When I turn on the serial print line, the wheels would jitter, the steering would jitter, so it was screwing up the freaking PWM software servo thing. And I'm like, okay, I'm just done with this. So, I mean, I wanted to use the radios. I like this idea of BLE connectivity and all the protocols and the kind of things you can do out of the box if you get past that learning curve. So, and I'm pretty sure that because the OpenMV cam is ESP32 and it's got Wi-Fi, I'm pretty sure I can attach it to my network and let it register with my MQTT server. So then I can have this thing. Of course, I could just hook up USB cable, right? But that's too easy. So, right. So I want to get this so I can connect to my MQTT server, and then I can use Node-RED and then just pull up the value. So just drive around. I can just watch it on a web page, watch the diagnostics values on here, and then see if that's what's coming across, and then say, "Yep, I'm done with Arduino. On to the next." Need a better connection than that UART.
Carl, I would throw in another observation here, and there are probably people in this group that know much more about this than I, but if the problem you're trying to catch is the program dying, crashing, that's not hard to find. But for the sort of things we do in robotics, there are other ways the program can fail. And the big systems I work with, big seismic systems I work with at work, it's the same thing. So there are lots of other ways. For example, you can look to be sure that it's generating some logging output at regular intervals, or you can look to generate just that it sets some flag on and off at regular intervals or something like that. There's a whole lot of ways things can crash without dying in a Linux environment.
Oh yeah.
So it can have quit working, but still look like it's running. So you can't necessarily trust just restarting a dead program. Okay.
I'm with you on that. So, I mean, to be clear, the so far adjacent, right? It's so tenuously connected to roboty stuff. But to be clear, I mean, this thing that I'm showing you here, this Espruino hub, this is nothing more than a gateway that would take the Bluetooth the MQTT protocol delivered over Bluetooth, and this thing. Oh, because I went. And this thing, all this does is, what does it do? It takes it recognizes the BLE connection, or actually, no, I'm all mixed up now because this one is even out of the picture. If I do that one, it's Wi-Fi. So that one is it's just talking to Node-RED over Wi-Fi. I don't even need this. Damn it. So anyhow, this is for another project. This is for if these guys send a value, they can send it by a BLE packet and send data out by just like a heart rate monitor or whatever, and then this gateway would take that that signal from one of these BLE dongles or BLE beacons, and then translate it into an MQTT message so that it could be picked up and used anywhere else. And the trouble I had is that it's just a stupid server, but there was some kind of, I don't know if it was my TV downstairs or something, but something was giving it with grief and it would crash every now and then. And I just wanted this service, just a gateway, to be up and running all the time. So the system control question was to get this service running up and running all the time. But now talking through it, I'm not even using that for my robot question. So when uncertain, when in doubt, find another project and run around until you hit in the wall, I guess. So what can I say?
It does bring up a question that I've often wanted to ask the group at large, which is how much time do you spend on true robotics oriented stuff and how much do you spend on integration nightmare stuff, right? What percentage of your time is spent on what?
I think you could read between the lines for my answer, but let's see what everyone else has to say.
I'm always stunned at how much work it is to generate user interfaces. You know, as long as it takes to make the whole rest of the robot.
Yeah, my PhD project back in early 2000s had 260,000 lines of code. And the vast majority of that was a really complicated Java Swing UI, which I will never, ever do again. What a nightmare. UI, yuck. Ugh.
I will agree that I like to call them problems I have to solve, not problems I want to solve. And those problems I have to solve far outweigh the problems I want to solve on any project that I'm doing. It doesn't matter whether it's software, hardware, whatever. You know.
I'll second that in spades.
But we have to be, you know, true to ourselves. A lot of times those non-robotics, those integration problems are in the category of problems we want to solve, right? I mean, a lot of times, you know, we want to try out this new microcontroller, and some of us, you know, they are famous in this group for trying out all kinds of different microcontrollers, you know, so it goes in the bucket of it's a problem we want to solve, yet it's not directly related to the robotics problem at hand. So it's you know, it's
fair comment, Chris.
That's fair. That's fair.
But you know, to go back, I was telling you about this big project I had, and nowadays, if I want to do basically the same thing, I can spin up a Docker image that does the graph database visualization, and it takes it's one line of code, and I spin that up, and then I send commands to it. And so I've written a command line program that is like on the command line, just tiny amounts of information. So I've offloaded all of that UI stuff to somebody else. Because I don't know about you guys, but I don't mind doing infrastructure code. It's what I do for a living. But God, and I've done UIs, but oh my God, they're painful. UIs are always just so painful. People who do UI code for a living, I think, are just like, I don't even want to talk. I don't want to have a beer with them, you know.
But don't you ever sit down, and I know there are a few among us here that write drivers, and look at that driver code, and it's just a little gem. Okay, it doesn't do anything yet, but it's so elegant, and it's just a little gem. And I'll go ahead and quit working today before I screw something up, you know.
I have an SPI library I did that lets a Raspberry act as a master and a Arduino act as a slave over SPI, and it works pretty well. So yeah, I'm with you, Dave. When you get that running like that, it's nice.
You look at the code; it's all nicely indented and commented.
Yeah, if only it was all like that. Well thought through, well structured, easy to read.
Oh, it's self-documenting.
Self-documenting.
I don't know, David. Sometimes I'm just happy that it works right. You know? Hey, it may be an ugly child, but hey, it works. You know.
It's funny, that project that I was telling you about, the big one with the UI, had an ontology engine in it. And I'm actually this week, this is a 20-year-old project. I'm actually taking that ontology engine, which has no UI, and I'm publishing it to the Maven Central Repository, which is, for people who are in Java land, know that that's like where all the Java code is. And it's my very first public publication of the guts of that project. And it will be now as a library available to anybody who wants to use it. And there's no UI. Oh, thank you, David. It's quite a proud moment. It's like 20 years of effort. I've been trying to get this thing up there, and I've got onto Sonatype and got a Jira ticket, and I've done all the things necessary. And so as soon as I've got the readmes and everything ready to go, I'm going to publish this thing. And then in your Maven POM file, you just put in the little dependency line, and you just import my library, and you can use it. It's like, wow, this is, and it will live on for years, and it's a gem, David. It feels like that. I totally know what you mean. It totally feels like that. It does this.
Live long and prosper.
Yeah.
Well, I can only say that it's good that we can take our satisfaction from things like that. Take it wherever you can.
Yeah. Yeah, it's either that or pulling mud out of basements, you know.
Alrighty. Well, cool. So let's swing around to Harold. Harold, I think you had some
Yes.
pretty steampunky looking thing over there.
Hold on a second here. I got to turn off some lights just because, well, you know, things need to be quieter. And
Harold, are we going to get a Disneyland report?
you can if you want, because I'll talk a whole bunch about it. But maybe that's too much for everything. So this is a lightsaber from Savi's workshop, and we got to turn off and turn on. And as you swing it, it does things. You can hear battle things every now and then. You see the green flash on it. We build these things in Batu, but you got to be careful because the first order's hanging around, and you can't ask where's the lightsabers? Where do you go build the lightsabers? Because lightsabers and weapons are illegal, so you have to ask for things like scrap metal and that kind of thing. And we had a real good experience turning it on. Yoda actually gave us a thing. It was really fun on that thing. But I, of course, on my stream last night when I got this home, I did take this thing as completely apart as I could just to show all the insides of it. Because if you can't take it apart, it's not really yours, right? And how that goes.
I love how it doesn't just turn on you actually get the effect of the extension as it comes out.
Yeah, you do. And there's actually a new lightsaber they're in works. You've seen prototypes of that in some of the advertisements for the new Galaxy's Edge Hotel that's going out. And it looks to be a bit longer on it, but when you turn it on, it actually extends out. They got some way of extending it out. The some kind of polyurethane plastic. It's really sturdy. This thing, I've got a one I print over here in plastic, and I'm going to finish building that too. But this probably weighs total. I hadn't weighed it, probably 3 to 4 pounds. I mean, it's heavy. It's heavy, and it does a whole bunch of things in it, like. I don't know if you could hear all that when you turn it on. It's got a hum going on that thing. Can you hear any of that as it's going?
Yeah.
And as you swing it around, it does make sounds and noises and all that sorts of thing as well. And when you turn it off, it goes away as well. They've done a really nice job of putting this together. For those of you interested, the total cost, including
Amber Alert time.
Yeah, everybody's gonna get hit by it.
She's 9 years old.
Yeah, I'm wishing that the best. That's just got to be horrible.
No fun.
Oh, an 8-year-old, a 9-year-old, and an 11-year-old. It's not just one person.
So there's some interesting things that they've done on this. Not to disregard that, I just can't do anything about that Amber Alert right now. what you do when you go in is you pick you got 4 categories of these shells, and I'll pull them apart here in a second and show you what you kind of get. But out of those categories, you're getting 2 of the injectors, a total of 4 of these sheaths, 2 kinds of switches, and 2 kinds of pommels, and you get to put them together. And if you had access to all of them to pick on them, there's over like 530,000 combinations. So if you have an exact copy of somebody else running around, it's kind of low. Although there was a lot of Lightsabers being made. The other cool thing is, and it makes sounds when you do this, the blade when it comes out, so it never really goes off. It has sounds and stuff, so you got a good indication that yes, I've got a good electrical connection when you put it in. This thing is basically pretty much RGB lighting, and I got a purple blade. I don't know if it came across in the video as purple, but it's because I've got in here a kyber crystal. Here, let me show you how that goes. I'll take it apart real fast here.
Here, this is from your your Disneyland trip.
Disneyland trip, yes, sir.
Okay.
Yes, sir. We did a hell of a deal on the Disneyland thing. I ran my wife ragged. I started off. We averaged about 18,000 steps a day. We normally average about 2,500 steps a day. So let's just say we were walking a little bit extra. I got stronger as the week went on, and Debbie did not do so well as far as that kind of stuff. So I kind of ran her ragged a bit. But she built a droid, which I'm not ready to show you that yet because she hadn't started playing with hers. It's an R2D2 based droid. It's a really cool experience too, where you go through and you're picking out bodies and legs and putting on headgear and doing things. It's a Bluetooth controller. What's going on inside this thing is you see how it's really well made. Really well made. These things are heavy.
Metal?
What now?
Metal.
This part here is plastic, but everything else here that you're talking to is metal. This black knob you see here is a place for the belt clip that goes on there. Every lightsaber looks pretty much the same once you take off its skin. And what sets the color, basically there's a Arduino kind of thing right in here. The batteries are in this thing, a hoochie. It takes 3 AA batteries. Not sure how long they last yet, but we're working on that. This is what sets the color. And it's they've got these molded up to be kyber crystals, through the Jedi lore and all the thing. And really what's in here is an RFID. So this one gets me purple, noted by the purple color. However, I've been looking online, and if I've got an RFID reader writer, there's a whole bunch of series of online of what codes to jam onto this thing to make my blade any color that I want it to be. Again, they've done a real nice job of this because this is really strong. In fact, I cross-threaded this bottom part here, and I had to get it. So I had the biggest channel lock on it, trying to not mar anything up, and a screwdriver sunk through here and pulling on this thing, and it held up. So this thing is going to last a long time. It's some nylon-based injection molded something or another. And again, they've done a real good job too, because I've actually got I've broken it loose so the battery was kind of stuck when it first came out, when I first had it. And so I'm like, how does somebody who's not me going to change this battery that has all this junk laying around to pull it out? But we worked through all that kind of stuff and
use the force.
Yeah, lots of force. And so this thing here it holds on to it, but this is kind of a spring-loaded thing. And when the battery's in well, and you spring load the thing and the RFID comes in play, I don't know if you've heard that, but you can hear it. You get an audible sound, and also you get a light that shows up here to say that you put it together well. So I mean, they've gone really far to set all this stuff up, and then the switch here is cool because red dot, go for where do you think red dot, where do the things line up? And when you do that, the switch is nothing more than a bit of plastic with with something embedded, some bit of metal, something embedded. So it's a Hall effect switch that kicks open to do all your lightsaber on and off on it. Really assemble it back up right fast. Goes on, and of course, you got people helping you and doing stuff, and you're in there, and Yoda comes and talks to you, and you have the lighting ceremony where you raise it up, and it's totally embedded in all this thing.
How long is this process, Harold?
I think if you count the wait time where I'm waiting out and we're interacting with the cast members about, where are you from, the Big E Earth? And of course, I said I couldn't say I'm from Earth. They asked me where I was from. I said, well, it's complicated. Do you really want the whole story? And so we had a good time with that. If you're sitting there during the wait time to get in, it's probably about 45 minutes total. And they drag you into the back room. And literally it's a back room because it's supposed to be this, hush hush thing going on. And it's all majorly themed out. If you go look online for Savvy's Workshop, you'll see complete video walkthroughs of all this stuff. And it's just like it shows in the walkthroughs. And there's probably about 20-25 minutes of ceremony and things that go on and building things and doing stuff. They give you a little badge so they know which set of lightsaber parts to give you. And at the end of it, they give you a nice big carrying case to put it on, to put it in to carry it around the park. I opted to ship it back, that and the wife's droid, because I just didn't want to be carrying it around and going through the airport. It cost me like $35 to ship both of those things back, and we got them within a week on the thing. And that's having to go through. Can you imagine how many people are shipping things from Disney? So, I got in line with all those folks. Oh, I got to show you this too. This is cool. So how they designed this, like if you didn't notice, I swapped these two pieces when I put them back together because I can't, right? But how they designed this, how they made this work, is they have a lips. Let's see if I can show you right here. They got a big lip right there, and so when you screw this on, if you'll watch the edge of that, see now I'm right at the edge of that, but then I keep screwing it, and I get covering up that edge pretty good. So you can't tell that you actually have changed all these parts. And they've done the same thing with this. If you look, see right about there, I am there, but then I get another turn or two on it, and now that looks like somebody made this thing and put it together. So it's really well made. And again, this thing is heavy, and you're saying like, well, that's a fake lightsaber. What are you going to do? I got this big horn here and about a 2.5 3-pound sledgehammer. I think I can probably do some damage to somebody if I really need to. Not that I plan on doing that, but it's a good size, and do the whole thing, and I think it's well made. I experience with the connector was extra. The connector was extra on it, so but out the door with tax title and a little bit of extra belt clip, because well, it just is, if I'm going to do the thing, I'm going to do the thing. It was about $250, and it was somewhere between 40 to 45 minutes of interacting with cast members and talking salvage and all that kind of stuff.
And you actually met Yoda?
No, I did not meet Yoda. No one met Yoda. What was happening, we were back in the back of Savvy's back room putting it together, and right before we initiated our first lighting of the all of our sabers, Yoda showed up in spirit. The whole room turned green, and he was talking to us about how the mystique and the origin of the Jedi and all those sorts of things with it. So it was pretty cool. It was really cool on us.
And he speaks in like reverse Polish, right?
Yeah, or something like that. Exactly.
Reverse Polish notation.
Yeah.
Reverse Polish notation speaking.
Yeah.
Fun speaking he does.
Yeah.
Yes.
Learn forth quickly, I will.
Yeah. So I know you guys have seen my ears before, and I got to interact with Ray and some stormtroopers and stuff. And they asked me, where I was from. I said, well, there's another person around here that's a little shorter than I am, because tall for my ears I am. That kind of stuff. I was throwing those things out. So all that kind of good stuff. And yeah, I am a 4-year-old when it comes to this, or well, telling a dirty joke, maybe I'm a 13-year-old, but I enjoyed all of that stuff. And we rode the two major rides there in Galaxy's Edge. One of them was Smuggler's Run, which some of you on my Facebook page has probably seen some of the stuff. Literally, they built what is considered to be a full-size Millennium Falcon. And so you get pictures in front of it and all those sorts of things. But as you're going in it, me and the wife were the pilots, and we had two gunners behind us and I got to pull the lever to jump to hyperspace in the Millennium Falcon and doing all that stuff. And exactly, well, see, that kind of thing right there. There's if you got everybody, you got a full complete thing. The way they take things so incredibly deep, because you're sitting in the cockpit, and if everybody in the cockpit knows the trick, when you sit down and you push all the right buttons, you have Hondo, which is a character telling you to go here and do that, or get behind it and shoot this, or do that, or whatever. But if you know the right buttons to pick as the door is closing behind you to start the ride, it puts it into Chewbacca mode, and you have Chewbacca giving you command like, you can control the ride experience if you know some of the secret tricks. And then and that was way fun. And literally, you're walking through, and it feels like you're in the halls of some of the movie scenes. They even have the holographic chessboard, but due to the My Sharonosaurus virus we got going on, they blocked that off, and you can't sit down and take pictures of being at the chessboard, because it is exactly it. And it was way cool. And then we came back and rode Rise of the Resistance, and that thing was off the charts. It's a trackless ride, and they have so many pre-staging things that are going on that ride probably, once you get into this, Ray comes up in a hologram saying things to you, and it looks just like it does in the movies. You go in there, and at some point, you're lifting off because you're part of the resistance, and they're evacuating you, and somebody attacks you, and of course they tractor beam you onto the board of a Star Destroyer. And let me see if I can find it just right fast, and I'll pull it up.
If you want a robot challenge, somebody's got it instructable to build a BB-8 droid that really works.
Yeah, there's a couple of guys out there. There's a couple of folks out there that do that.
Harold, are you talking about how they've actually designed the waiting line to be interactive? And
yeah,
right.
Part of that is exactly right. Let's see if I can find me a good picture of it. And so what happens on it? It's Galaxy's Edge. No, that's not what we want to do. What they do is the very first starter, after you zigzag through a while, you will come to the first staging area, which it's kind of an outdoor thing, and you're looking at a black X-wing fighter. Poe Dameron's X-wing fighter is hanging out there. So you're hanging there, and you see the side of the ship that's going to take you off, and so you go into that. The door's open. You go into it. You have an animatronic Calamarian, the guy with the bug eyes. It's a trap guy. he's over there and he's kind of the pilot, kind of the commander of the ship and kind of the shuttle, and you got a pilot thing going on, and you've got windows and stuff looking out, and you take off, so you feel it rumble, and as you look out the windows, you see space stuff and X-wings flying by and TIE fighters coming at you, and then of course you go in this door, and at some point you get tractor above the Star Destroyer, and they open the same door you just walked in from outside, but when you step out on side of it, out of that, you're on a Star Destroyer. You're on a Star Destroyer. Okay, I gotta find this now because I really want to show you the picture. Come on,
Harold, contagious your excitement is.
You are a 4-year-old.
I told you I am.
I envy you.
I am not. You think I would? You think
Now,
I would
Harold,
lie about that?
We have at my work this little room. You go in and you close the doors, and when the doors open, you're like in a totally different room.
I don't know how their elevator does what it does. They did it. And I'm not getting. Hold on.
Except the new challenge you have.
Yeah, hold on here. Make sure it comes up. There it is.
You're about as organized as a 4-year-old.
Yeah, exactly. So when you walk out of the
better.
shuttle, when you walk out of the shuttle, you walk onto this flight deck, and you have all those stormtroopers looking at you, and you got another person there like that's dressed up in the command stuff. You resistance people will move here now. You are going to go on the blue line. You should not leave the blue line, and remember that what blue line you are on. Just like matter of fact, the whole thing. And you got AT-ATs firing at you at some point. Lightsabers come through the wall. The resistance blows open another wall. Kylo Ren comes up and shakes his finger at you. And you run past a bunch of turbo lasers and stuff. It's insane. Literally insane, the level of detail they have. This is a mock-up, but essentially you're doing that. You're running around inside a car driven by a droid that's doing things and moving you around. And it takes a good 30, 40, I'd say 25, 30 minutes with all the pre-staging and all the stuff. There's an example of what hallways you're going through and that kind of stuff. It's fantastic. I mean, it's fantastic.
Took you there, they did.
Well, now, yes. And there's a look at one of the things you're running around in. And it's a trackless ride, meaning there's no tracks. I mean, you see tracks on the floor because they're of the different places you've run across, but there are no like rails or anything. It's all basically robots running around it. The vehicle in front of you and the vehicle behind you will take different tracks. You're doing the Carl slide and side motion on there because they've got just the wheels are probably, I bet they're swerve drives of some sort, doing that thing, running around and moving around, and you all end up in the right place, and you get dropped back onto the planet and all those sorts of things.
Surprised you didn't jump out to inspect the drive. You said, "Are you using a swerve drive?"
That would have been fun because I'm thinking that as fun as all of this is, and as cool as all this is, there's something in the back of my head like, how is all this working?
Somebody gets
some of it with screens and stuff, but
people earn a good living building that stuff, don't they? Oh my goodness,
they certainly do. I mean, like I've been telling a couple people, as far as regrets go, like you always have, the older you get a little more regret here and there. Most of my regrets are very, very frivolous. Like, I really should have asked that girl out, that kind of stuff. But when I get down to regrets that actually matter, I did apply at a college. I did apply for Pixar, not Pixar, Next. It became Pixar. That didn't go anywhere. And the thing I did not apply for that, because for some reason I thought that it wouldn't go, and it would be Imagineer and Disney, and I think that would be a hell of a job for doing all kinds of things. And I just did never apply for that. People are like, well, you can still do it. It's not too late. Well, there's some realities. I got my mom. Debbie's got her parents. You got all those things that are now technical debt in the computer world, we call it, that have built up that you have to take care of, that makes some of that much harder than it would have been if I was a single person out of college wanting to move to Florida to be an Imagineer. So that kind of stuff. But no, it's a hell of a time. The whole place is great. If you're into lights and stuff, their newest Harmonious in Epcot is amazing. They're literally using water sprays as screens. So you're spraying water and you're spraying some fog and some other stuff in a bunch of way, and that becomes the screen they're projecting upon. And then things like the Magic Castle and other things, they're doing their projection stuff where you get all kinds of wacky, fun stuff happening on the castle. And it's simply because they've got the projection mapping so well done and jumping around. It's just impressive. Yes, I'm 4-year-old, but I'm also looking at all the tech stuff that's going on. Oh, and by the way, it snows on Main Street every night while you're sitting there after the fireworks are over.
It does here too.
Yeah. This though is thanks to a cat named Kevin James that figured out how to do that in the magic world, made it snow inside. David Copperfield uses his effect all the time to do that. It's some kind of soap. It dissipates fairly quickly on the whole thing. It's some kind of soap bubble that they got going out there. But anyway,
The
that's
same
all
thing here. It takes about 45 minutes of snow blowing and it disappears.
Anyway, I didn't mean to take all that time and get so into Disney and whatever. And
How excited you were.
Yeah, excited.
Sure, you must.
I have to say that actually, Harold, all that time I managed to actually flash my board with MicroPython. So I now actually
I'm glad
have
I can help Murray.
MicroPython
I can
here.
help Murray. Awesome.
Okay, so it's like we have a new measurement, a unit of time here is one Herald. One Herald is it's the amount of time it takes Murray to flash MicroPython onto a processor.
There's got to be a star just for that.
Yeah, but you guys can tell I am very happy about it. I'm very passionate. I will tell you, the other ride that I rode was in Pandora, and Pandora was way cool because at night, if you say Avatar, the thing where you got the big blue aliens and stuff, and we all felt a little weird thinking the blue alien girl was kind of sexy, and we're like, no, that's alien. We can't be doing that. So okay, maybe that's just me. But anyway,
It's just you.
but anyway, like in the movie. How you had the bioluminescence, the whole section of this park is bioluminescent when at night, and you line up and if you hit the right route and the right thing, you make sounds and drum sounds, and if you hit one of the pods in just the right way, you'll get fog and things burping out of it. But the big ride there was something called Flight of Passage, and you are effectively on the back of one of those banshees, one of those flying birds going on there, and you're sitting down on something like a motorcycle, and they lock in your feet and lock in you, and you're holding on to the motorcycle. They put the 3D glasses on. You got this blank steel wall kind of in front of you. They fog it up, flash it a little bit. And so that allows them to draw the wall up without you actually seeing the wall going anywhere. And then you have the 3D screen with your glasses and things that's going. It's amazing. And then they do a motion ride for you, and you're like, wow, and all this stuff. But what you first notice though is that when you first get mated with that avatar driving that, you feel the things pressing on your legs, actually pressing out. They've got air bladders in there simulating the lungs of the bird you're riding on, so you can feel it breathe. It's just insane. It's insane. And so we rolled that one as well. So it was
And
really.
Harold, you paid to be mated with an avatar?
Yes. Exactly.
Okay, team trip, we're all in.
So how many days did it take to go through that park? Do you do 1 day, 2 days, or?
It can take as many days as you want to take, to be honest.
I was thinking that because
the stuff is way deep. Like even in Galaxy's Edge, we spent the majority of the time there in Hollywood Studios. We were there for we were at their rope drop, so we were there at 8 o'clock in the morning, and we left about 3 o'clock in the afternoon and came back for dinner because we had reservations at the Brown Derby. And and the majority of the time without being at the Brown Derby, that 8 till the 2 almost 3 o'clock was spent uh in and around Galaxy's Edge doing stuff. Of course, we had to eat and a few other things, but um, even if you did what we did, we built a droid and a lightsaber. They have an app on the phone, the Play Disney app, that knows you're inside of Galaxy's Edge. So as you're walking around, they have QR codes on all these boxes. You can start looking for uh, contraband material for the First Order, or find out ways to scan some other stuff to help the Resistance. And they got all these games you could play. So I would say if you're going to do this, if you're not already a marathon runner, if you're a marathon runner, it's a different story, a little bit different story. But if you're a normal, average individual, I would say that you plan a day per park.
Right.
You plan a day per park, and you pick a couple of the big things you care about, because there is absolutely no way you're going to do everything, and that's in air quotes, everything, right? Because as soon as you think you're finished in an area, there's something that goes one step more that you didn't notice, and now you do. It's just amazing on how deep they go, and you might not care about it, but well, I'm not that geeky. I don't care about that geeky thing, but I care about this geeky thing, and so we're going to do it over here, right? And so at least a day. Magic Kingdom, we actually did about 2 days total, because we had the after hours Christmas party that we paid extra for. That was hella cool, because it's a hard ticket event, and they run everybody else that's not out of the count thing out of the park. And so literally it's like 4,000 or 5,000 people in the park instead of the 30,000 people that could be in the park. And rides are easy to get on. And oh yeah, Cinderella thinks I'm friggin' cool. I'm just saying. Oh, I had my glasses on, my LED glasses. I coated them up in blue and said Cindy Rocks on the thing. All the cast members thought that was the coolest thing ever. And I went in there, and Cinderella seen that, and she went on this whole big diatribe things and this kind of stuff. It was really a great interaction on the thing. It was fantastic. So we effectively spent a couple of days, but they got all split up and disjointed in the thing.
Oh, yeah, I was there probably 15 years back, and sounds like they've improved technology since then. I mean, one of the rides back then, they had the screen that, and you're right about how the seat, you felt the movie, and that, it was interaction at mid-time, and they do fine details like that.
You probably rode Star Tours if you were in MGM Studios, is what they called it back then.
It was, or Hollywood. I forget the name, but I just remember that. It was. Felt like you really were in the movie.
Yeah,
it wasn't
like in the movie.
Right. It wasn't a matter you were watching it on a screen. You were literally wrapped around it.
Mm-hmm. And and you get hit and stuff, and they've done like in the Smuggler's Run. They just don't have one cockpit of the Millennium Falcon. They have like 6 or 8 of them. And so what they've done is they run you into one, and then when you exit the vehicle, you're not in the same place you went into it. And so what they've done is, as you're in there, as you're being cycled around, literally like a big gear, they run you in there, and as things happen in the during the ride, like you get hit, so you shift left a little bit or shift hard because you got hit, slammed on one side or the other. That's when they're actually rotating you to the next section in the cog, and then at the end when you get popped out, you get popped right out, and you go, of course, into the gift shop, and there's all that stuff that you have to do. They've done that. They've done that so well, you don't know you're being repositioned, and you are the entire time when you're riding the ride.
Harold, I have to take exception to one thing you said.
Okay.
You said, so if you're just a normal average person. Now, the DPRG has been known by many names, but I don't think that's among the list.
Well, let me put it in context. As far as physically walking around and that kind of stuff, and just going to work and coming home and that sort of thing, if you don't actually do a little prepping for the walking, because literally 19,000 steps a day, and I did not think. And I was playing a big old game of Tetris, right? I got schedules. I have things where I've got reservations. I've got wait times. There's things in this side of the park and things in that side of the park, and I don't want to ping pong back and forth and that sort of stuff. So I was playing Tetris with all. So that was a fun programming problem, actually, a program logic thing. I was having a good time with that. So I tried to minimize those steps as much as I can, and we were still clocking in 19,000 steps a day. Yeah. So in your context, you're right, David. In your context of if you're not used to walking that much and going that much, any more than one park a day, and I don't know that you could do a full open to close kind of thing, because we didn't really do that. We either left early or took a break outside of it in the middle of the day and that kind of stuff to recoup, so to speak. Yeah, it's hella fun.
Okay, so we have a question. Speak next, who will?
I think Ray had his hand up.
Ray, like Yoda, you must speak the whole time. Could you imagine?
No, I don't have anything to present.
Oh. All right.
Waiting on parts.
Waiting on parts. Parts is parts.
So that's like the standard excuse now, right?
Okay, so it's a really hard act to follow.
I had some really cool stuff I was going to show you, but I'm waiting on parts.
Waiting on parts, yeah. I pulled a Murray.
I can show what I'm planning on getting for Christmas if everybody wants a quick look.
Sure.
Bring it up.
Let me this is the Amazon item that I'm getting. It's a car. I think it's a radio controlled car.
It's a good thing you're not getting the kid.
Yeah.
Well, that's kind of not legal at the moment.
I don't think there's sound, but here's an example of it running around. So just imagine take the truck thing off and put a robot on top of it.
And it actually goes in water?
Make it autonomous. That's my plan. So I was showing not the video, but the Amazon link to this, I think at the Saturday group earlier in the month. But I thought I'd show the rest of you too.
Cool. It looks like it can handle curbs. A lot of those vehicles have a real hard time with curbs. But that one looks like it can handle them no problem.
So anyway, let me get back over here.
It looks a lot bigger in the picture. That must be a small kid.
It looks a lot bigger.
Yeah, I think it's a small kid. So anyway,
like,
that's my plan. I'm going to turn that into the base of my autonomous robot that can run around outside. And
Cool. I have a very similar. I have a very similar plan on mine as well, is to get something very similar to yours, and then I think I'm going to probably have to beef up the suspension a little bit once I put all the robot bits and pieces on top of it. I saw what I really wanted though, but paying $1,000 for something I'm going to tear apart seems a bit much. One of those Traxxas X Max, those things are really impressive, and if you have a moment, we got a Traxxas place up there in McKinney, right? So go in and check one of those things out if you got nothing better to do on a Saturday or whenever the store is open there. I did that, and the way their bases are built and how strong they are and structurally, and it's a great body, but it's a grand, and if I was into it, maybe there was something going on there, but I'm just going to get something to tear apart. And
that's not just a Traxxas store. That's the main headquarters.
Yeah.
That's where all the design and everything. Just as a side note, Mike Hamilton, that designed the 6-wheel robot that I have, was a designer for Traxxas. Built some cool things. Those guys are real serious about those radio control cars.
Yeah, they are.
So is that in Plano or something?
I think McKinney, Allen.
McKinney?
Somewhere up there.
Yeah, it's just west of 75, up in the McKinney, whatever. If you look up the address of Traxxas, it's there. I happened to be in that area for some other reason, and I extended my lunch by about 20 minutes to run in the store. Just look at it; it's impressive.
We
Who
thought
else is waiting on parts? Oh, go
we
ahead,
thought
David.
we would try to talk them into manufacturing some J-bots for us, but you know, we could guarantee tens of sales.
So what did I see in this this email stuff about some bulk purchase of some crazy outdoor robot? And
yeah, that thing looks crazy.
Oh yeah, Kareem, did some of us buy robots?
I think so. Yeah, it's a mystery to me. You know, they have these hard requirements that you must pick it up by 5 days beyond the auction date and all that kind of stuff. I already paid for them, but the shipping place closed like the day after, and they're closed for a month. And so it's not going to be until January 13th that they open up again. And so shipping was like all messed up, and I still have no idea what's going to happen there. And so I will email the group and with updated information when I figure it out, but it's not going to be until I think the earliest we can try to contact them is January 10th. And they're not opening up for shipping until the 13th. And so it's only then that I'm going to find out what the true cost of it is. But yeah, I bought 6 robots of the,
Cool.
you know, there were, I couldn't really figure out, I found a price list from, 2004 era, when I think these things were built. Not actually sure of what, what generation these are, but, you know, I couldn't find a direct match to their configuration. Like there was one where the chassis itself, without any of the sonar arrays, any electronics on board, was going for 6,000 each.
Whoa!
And then and a populated version was going for like 24,000 each, something like that. But the electronics have no value anymore, except maybe the sonar modules are still usable, depending on their condition. So that's another thing. I have no idea what condition any of these are in. So we kind of bought them on some kind of faith, and I'm just looking to recover my costs effectively.
Well, Kareem, if you're going to take a big hit on that, you need to let us know. You shouldn't have to absorb that alone.
I appreciate that. Yeah. Well, I'll let you know. I mean, right at this point, I can't know. Yeah.
From the pictures, it looks like they were, rode hard and put up wet.
No, that's true. Yeah. I have no idea what the condition of them are. This is something I was struggling with. Do I want to, I think the plan was sort of originally share the risk. We have no idea what the condition is or how usable any of the individual parts are. And so I'm going to favor people who sort of opt in early on. But there are some people who just don't want to commit until they've heard something about the condition of the units. And so I think I feel comfortable charging a little bit more for those to help recover my costs if people are going to make late decisions about it. But there's a lot of interest. I got a lot of people who have been contacting me off list, directly.
Cool.
So I'm sure that they will move once we get them, and it's just a question of exactly how long that's going to take.
So no Vegas road trip then, huh?
Even if they're not functional robots, from the pictures, just the mechanics and the wheels and all of those sonar transducers and their special, there's lots of things to part out from there.
Yeah.
Or you'd think that it's got to, if that level of robot was there, you should have some good bones, so to speak, with a chassis and all that kind of stuff to build upon. You'd think.
Yeah, I think so. But if there's like damage to the belts on one or two of them, I don't know how to replace those, or what the approach might be. So there's some unknowns.
You just 3D print them. Murray's
well,
yeah,
you
3D print them, right?
You buy them from McMaster Car just like they did.
There you go. Yeah. If you can find the right part number.
Yeah. Oh yeah, and speaking of shipping, Carl, we both got the dual pack of the Pocket Pro, and so I posted a question on the forum because people should have gotten shipping notification and have these things in their hands, and I haven't got a shipping notification yet, and so I posted a thing, and since we bought the dual package, not the super early bird package, the dual packages will not start going out to the end of January. And I'm like, okay, wonderful.
That's well, I'm glad you got a feedback on the forum because I sent a direct message and they haven't replied yet. And I said, look, people, backer number 62, and you're shipping people, you're placing other shipments out before Christmas, advertising new sales. I mean, come on.
I would have thought backer number 62 would have been shipped out regardless, whatever the package number was.
I mean, yeah, no, it's they play the other. So yeah. It's this. I believe this happened last time. This is a Kickstarter where they had a nice delivery date and they were 2 years late. It's a really nice product when it finally came, but it was.
Yeah, like I said, I'm backer number 366. So me being behind, you and others, that's totally expected, but not expected because I bought a different package. Yeah, and I bought more of them. I would have thought.
Yeah.
Hey, did anybody choose the more expensive shipping on the Oak D lights? I went for the cheap shipping.
I went for 3 to 5 business days.
Yeah, I went for there was 3 options and I took the middle option. The one that was about $40-something.
But I still haven't signed up.
Yes.
But I didn't know what Harold knew, but since I bought a dual packet, it sounds like I'm squirreled too until January.
No, Harold's talking about this Bluetooth. I think he's talking about this Bluetooth.
Oh, okay. No, I'm not talking about the old
different.
Yeah, I didn't do the other one. I didn't do the other the Nerd IO or whichever the thing you was just talking about.
Oak D Light.
Oak D Light, yeah.
Oak D Light, right?
So anybody hear anything on the Oak D Light? I'm sorry, I had to step away for a minute. Yeah, and I heard they were going to ship them. Anybody hear anything else besides that?
I ain't heard nothing.
I've paid for shipping and everything. You mean, are you questioning when they're going to ship or if they're going to ship?
When they're going to ship. Otherwise, when I made my, I did the, they give you a number and it was a credit to buy and you selected everything. I did all of that. But the one, but supposedly they were going to send a notice when you that you could, know that it would be actually shipped. And there was also, they had some, you could download an app called Shop, which I didn't want to do, where supposedly you could track it. But I didn't, that this would be the one time I'd ever use that app. And I didn't see any reason for doing that.
Are they shipping from China or is it
Hong Kong?
US first?
Hong Kong, yeah.
Yeah,
It's coming from Hong Kong.
It seems to me that it was said that it was going to ship in December, though. I thought.
Yeah, that's what they said.
Yeah.
And my number is pretty low.
Next year, but that's about as good as I can say.
Yeah. So nobody's heard anything new. Like nobody got a notice that said it's in the mail.
No, not yet.
Okay. All right.
I did sign up for the shop. It's a shop. They're using the Shopify as a service, and they're using that as the tracking.
Yeah.
But I hadn't gone in there to look at it yet. It says track automatically, but then you got to connect your email, and I haven't done it yet.
Yeah.
On their Discord, they've been hedging their shipping promises heavily. So, yeah.
They said they were going to send everybody who was going to be shipped in April. They said they were going to send theirs too, because they managed to overcome their supplier problems that they were running into. So supposedly they're making all the units, even the ones that were scheduled for later in the year.
Yeah, but now they're going to be stuck in a ship offshore.
Galaxy S5.
Yeah, that's probably right.
I had an Intel RealSense that had originally been promised to ship in October. I bought it during the summer, and I just got a shipping notice yesterday that it was on its way.
Oh, wow.
Well, yeah, because I ordered these in October and I just got them on Monday. So
All right. Well, okay. So it comes down to ordering or waiting on parts, right? That's the catchphrase of the day, isn't it?
Hey, I got one little thing I might want to show.
What's up, Doug?
It has. Let me
Doug,
see if I
before
can
you go
find
on,
it.
Before
I'm
you
sorry.
go on, I had a
Yeah, but-
question of Kareem. I did not understand any of what y'all were talking about with these robots he was buying. Was that some notification I missed?
It was a long discussion on the mailing list. These
must
were auction robots that
Yeah.
I don't remember how it first
Pat
came to our
found
attention.
it. Pat found it.
Yeah, right. Pat found it, and I had a sense from the bidding that there were some other robotics groups who were also interested in it, but they went well beyond the initial low advertised starting price, and but it was a packet of six robots. It should be on the list as cheap robots or something like that. Was the
So what did you end up paying for them?
it was 14 something
For six.
For six, yeah. Like 1450 or something like that, but that was before taxes and processing fee, the auction fee and stuff like that. So the total was closer to 18 something, and then there's shipping to get it to Dallas. It's a pallet. It's like 280 pounds or something like that.
Well, good to know. As Doug Anderson said, you shouldn't have to eat it all. So if you end up stuck with one, keep me interested.
All right. Yeah. When I finally get, I don't want to keep like churning the list. So when they actually show up, or at least I get confirmed shipping, that's the next time I'll send something out to the list.
Okay.
To
Thanks.
see what the opportunities are for snagging one of them.
We'll let Doug Paradis go on now.
Okay. Let me see here. I just ran into this and wondered if anybody had any experience with this particular application. Okay, let me. All right, here we go. Has anybody seen anything about this? It's a web-based tool that makes creating machine learning models fast, easy, and accessible. It was initially, I found it through, did a search. I was doing a search for machine learning instructables, and I came up with this particular one. And he's talking about it, and he mentioned this, and this is what they have. Two models. They have an embedded model, and then they have what they call their normal model, which would be like something that you would run on a Raspberry Pi. And this one's actually made for the nano, the ARM-based nano 33 BLE sense. And I'm just curious if anybody's had any experience with it. It's supposed to walk you through the capture and everything. Okay, let's see if I can find it here. What they talk about it. I'm not sure it's going to show it. They talk about somewhere. They talk about the different. So here's basically the whole idea. You gather your images, and I think they have a pre-trainer. I mean, not a pre-trainer, preconditioner so that your images are the right size. And for example, the embedded, they're 96 by 96 in their grayscale. For the regular ones, I think they're about 250 by 250 in their color. None of this, anybody had any run with this at all? Let's see if I can find it. And somewhere you get to export it. I just wondered if anybody, because it looks really easy and kind of interesting.
What's the underlying AI engine?
I'm not sure because I did somewhere. I can't put my hand on it right now, but somewhere they did talk about it. For this
I see
one,
TensorFlow Lite right there.
Yeah, that's for this one. This is for the. I don't know what it is for the normal model. Okay, because this one here though, it's the Lite, TensorFlow Lite. So.
Well, Lite is appropriate for things like Arduinos and
Right.
Android and stuff like that.
Yeah. So I just wondered if anybody had seen this or tried it.
Not here.
Not here. Okay.
I get the impression that there's a handful of services and tool flows like that.
Yeah.
Yeah.
It's cool to see, but it almost gets back to the STM discussion we started off with, which is that at some point there's a learning curve in a mountain, so you got to pick the mountain wisely because you might be there for a while.
Yeah.
I'm not real familiar with a term called PyTorch. Probably some other people have heard of it.
Yeah.
I think it has to do with machine learning, and
It's a big engine, it's like a competitor to TensorFlow.
Okay. So the reason I brought it up is that
These are TensorFlow.
I get emails from a place called Pi Image Search, and they were talking about let me back up over here a second. They were talking about a university or a place. I'm not going to do that yet. I was fixing to demonstrate my screen. I see Doug's still at it.
Oh, okay. I'm going to stop sharing. I'm not finding what I was looking for. So.
Okay. I won't be too long. I just wanted to show this email I got in case it's kind of on topic to see if anybody else was interested in what this email was about. I don't know if this font is big enough to read, but they're talking about this a repository for code for the PyTorch, and they have this link here. It says, it's a hub where everybody puts their stuff and you can download it and tweak it to your results and things like that. So I just thought I'd throw it out there since you were talking about a similar thing. I'm not at a point yet where I can even talk about it.
Well, I'm starting to think about how I want to use my OD Lite, and I'm also revisiting some of my other things that I've been playing with in the machine learning forums. So my interest goes through a cycle, and I'm now getting into the machine learning cycle part of my cycle. So
if you go to Pi Image Search, the guy wants a ton of money for the full university course, which is like $1,000.
Yeah.
But if you can sign up and get a whole bunch of free tutorials. I've signed up, and I've just scratched the surface, but I must have received at least 24 tutorials by email so far.
Yeah, I use his tutorial on how to put OpenCV on a Pi to put OpenCV on a Pi, and it worked great.
Yeah, that's very good. Very thorough.
Yeah, very thorough, and one of the most clear ones that's out there.
Yep.
Yeah, in his tutorials, he explains what every single line of code does in his Python code.
Yeah.
And I don't think you have to pay for anything. I think if you're looking for a specific example, you can just do a search, and he's got a lot of that stuff just on his website or links to it.
Oh yeah, I would. His courses, I actually own, I think, one of his OpenCV courses. That one of the ones he first came out with when he wrote his first book or something like that.
Yeah,
they were a little more reasonable in price than they are now.
Doug,
He's
had
a lot of inflation.
Doug,
Yes.
did you put a link in the chat
On that? Okay.
Yeah.
Well, it looks like somebody already has. Carl's already done it. So it's in the chat. But
that guy from Pi Image Search, he is in the business of making some money. He has a
Oh, yeah.
lot of free tutorials. He's got a number of paid services
Right.
you can sign up for. I found it to be quite useful. It's just, I played with this stuff when I first got it because I signed up for one of his $400 courses. I thought, he gave me some good stuff. I'd give him some money. And it's really good. I'm just not ready to use it yet. I hope it's not a mistake by the time I get ready.
yeah, I know what you mean, Doug. I've run into some of that myself. Otherwise, it's going to take a concerted push in that direction, probably taking about 2 months before you get the feeling comfortable with it, is the way I feel it. And up to this time, I've been willing to commit maybe a week or 2 weeks, which is just not quite enough to make it stick. And but every time I'm
overcommitted.
Yeah, same here.
But it's on the timeline somewhere. Once I get a few things out of the way, then I'm on to the OpenCV and the machine learning. We'll see.
Well, if you want to get a real nice introduction to OpenCV, there's a YouTube channel, and I believe it's really called just OpenCV. He's a gentleman who's either from Pakistan or India originally, and he does a great job. And he's a natural born teacher. Let's see if I can find.
Is his last name Malik, M-A-L-A-K, or something like that?
M-A-L-L-C? I'm not sure, but he's really, like I say, I definitely recommend, and he offers a few free courses too. Oh, okay. It's called Computer Vision Zone. Okay. I believe there is what they call it. And let's see here if I can get, he just released the sample. Let me see if it's going to load up anything here. If it is, I'll put the link. Yeah. Okay, this is the guy. All right. And if you look through his channel, you'll find there's several.
You're not sharing or putting anything in the text chat.
Oh, okay. Well, it's coming into the text as soon as I can get to the right window here. All right, here it is. This is the guy. All right.
Yeah, right. That's the guy.
Okay. This is good. Open. There's a few other things besides OpenCV. I mean, he does do some of the neural net stuff, but I think most of that is you might have to pay for. Here you go. This is the channel. Let's see. I guess I can do that. This is the guy. It's called CV Zone.
Yeah, I think I've seen that guy around.
Yeah.
He has a hand.
He has a hand. That's right. But somewhere along the line, you can see here, if you look down in the comments, he has a lot of different courses. Some of these courses are free, but most of them are you have to pay for. But it's really good.
Hey everyone,
So,
welcome to my channel. In this video, we are going to learn.
Where is the link to the Arduino related section of this, Doug?
let me see what I can find. Computer vision. Okay, I think. Okay.
I don't know that there's a whole lot you can do on Arduino with computer vision.
No, but what he does, he does do something. Let me.
Doug showed some pages at the beginning of his talk about Arduinos, doing something with Arduinos, and
Yeah. He's basically using OpenCV to drive. Let's go to the courses here.
You can do it with an OpenMVH7 attached to the Arduino.
Yeah.
Okay. So, all right. Let's see if he's okay. So here's one that's free. This one is free. I want to say that I think I've done this one. And in that he does use an Arduino, but the Arduino is actually is really just an actual, he's just sending commands to the Arduino to do sensors and stuff. The real trick is, and I'm trying to think of what he's using to. So in this course here, you plug in an Arduino into your PC basically, and your PC runs. Well, you run Python, and then Python sends commands to your Arduino. All right, so the Arduino isn't running OpenCV. That's not.
The Arduino blinks an LED, probably, right?
No, it's more than it's more than that. But I would like I say, you can look at the course. Let's see. Well, let's just grab this one. Let's see.
Never mind. I didn't want to derail you, Doug. I just picked up on you saying
okay.
At the beginning and just wondered what the heck that would be.
Yeah. Anyway, I do reckon I have taken some of his courses. I mean, the free ones, and they have been good. Especially, it depends on how knowledgeable about OpenCV you are. If you're not very knowledgeable, you're going to learn a lot. If you're real knowledgeable, you might still pick up some pointers. So that's but it's really cool. I just wanted to share that. Sorry, I was a little disorganized because I wasn't really planning on showing that. But I'm not sharing anymore, am I? No. But that would be one that I might take a look at. And I wanted to look at that other one that the links are, the teachable machine. I want to see what that can do. I've been told I'm going to get a Movidius stick for Christmas, so I'm kind of happy about that. We'll give that a shot.
So we're all waiting on Santa in one form or another. Parts is parts.
Mm-hmm. Parts is parts.
Parts is parts. Oh, yeah. All righty.
Batteries.
All right, and so moving around, anyone else have some updates we haven't touched on yet? All right. A quick show of hands. I was planning to have the call again next Tuesday night, whatever that is. Others will be online too. I see. Okay, good. Okay, so we can regroup after Santa's sleigh makes his deliveries, and that would be good. With that, I guess I move to adjourn. And if there's no objections, I bid you all a very nice Christmas and a relaxing weekend and long holiday. And
enjoy the warmth.
The others, stay warm.
Lack of snow.
Happy
I don't know
Christmas,
what
y'all.
the temperature is, but I think they're going to be like 80 degrees here. So yes. I'll take care.